Today, we begin our study of probability. Probability is about measuring how likely something is to happen. The value always lies between 0 and 1. 0 means impossible, and 1 means certain. Let's look at some examples together. Example 1. Choosing a student. We have 3 classes. Class A has 26 boys and 23 girls. Class B has 22 boys and 37 girls. Class C has 24 boys and 28 girls. Teacher Ivy wants to pick one student at random. What is the probability that the student chosen is a boy? Step 1. Let's count the total number of students. Class A has 49, Class B has 59, and Class C has 52. Together, that is 160 students. Step 2. How many boys in total? 26 plus 22 plus 24. That makes 72 boys. So the probability equals the number of boys divided by the total number of students, 72 out of 160. We can reduce that fraction to 9 out of 20. So the probability of choosing a boy is 9 over 20. What did we learn here? This example shows the basic definition of probability. Probability equals favorable outcomes divided by total possible outcomes. Example 2. Tossing a coin 5 times. Now let's toss a fair coin 5 times. We ask, what is the probability that we see at least one head? First, let's figure out how many possible outcomes there are in total. Every time we toss the coin, there are 2 choices, head or tail. That is why we multiply. 2 choices for the first toss, times 2 choices for the second toss, and so on. Multiply this 5 times, and we get 2 to the 5th power, which is 32. So there are 32 possible sequences. For example, head 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 head, that is one sequence. Tail 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 tail, that is another sequence. Head tail head tail head, that is yet another sequence. So yes, altogether there are 32 possibilities. Now, how do we count at least one head? We could break it down. Exactly 1 head, exactly 2 heads, exactly 3 heads, exactly 4 heads, or all 5 heads. Each case has many different arrangements. That becomes very complicated. So instead, we use the complement method. The opposite event of at least one head is no heads at all. That means all tails. There is only one sequence like that. So the probability of all tails is 1 out of 32. Therefore, the probability of at least one head is 1 minus 1 over 32, which is 31 out of 32. What did we learn here? When direct counting is messy, we can calculate the complement event, which is often much easier. Example 3. 2 balls with replacement. Now let's look at a bag problem. In a bag there are 3 white balls and 2 red balls. Sam picks 2 balls with replacement. Replacement means, after picking the first ball, he puts it back into the bag before drawing again. So the total number of balls stays the same. The probability of picking a white ball in one draw is 3 out of 5. The probability of picking a red ball is 2 out of 5. Now, what is the probability that both balls are the same color? Let's look at the case of 2 whites first. The first draw has probability 3 out of 5 for white. Because of replacement, the second draw still has probability 3 out of 5 for white. To find the probability of both happening together, we multiply. 3 over 5 times 3 over 5 equals 9 over 25. Another way to think about this: multiplication. When we look at 2 draws together, there are 5 times 5, that is 25 possible pairs of outcomes in total. Among them, 3 times 3, that is 9 pairs are white and white. That's why multiplication of 2 probabilities works. Now the case of 2 reds. The chance is 2 over 5 times 2 over 5, which equals 4 over 25. Now, how do we combine these 2 results? Here is the key idea: both white and both red are 2 different exclusive events. They cannot happen at the same time. So we add their probabilities. 9 over 25 plus 4 over 25 equals 13 over 25. So the probability of getting 2 balls of the same color is 13 out of 25. What did we learn here? When we want the probability of one event or another exclusive event, we add. When we want the probability of 2 things happening together, we multiply. Example 4. 2 balls without replacement. Now Sam tries again, but this time without replacement. That means once the first ball is taken out, it is not put back. So the total number of balls decreases. Let's consider both cases. Case 1. 2 whites. We want to know how many ways to pick 2 white balls out of 3. That number is 3. How many ways to pick any 2 balls out of 5? That number is 10. So the probability is 3 out of 10. Case 2. 2 reds. There is only one way to pick 2 reds out of 2. Again, the total is 10 possible ways. So the probability is 1 out of 10. Now we add the 2 cases, because 2 whites and 2 reds are exclusive events. 3 over 10 plus 1 over 10 equals 4 over 10. Simplify that to 2 over 5. So the chance of getting 2 balls of the same color without replacement is 2 out of 5. Instead of using combinations to count the number of favorable and total outcomes, we can also use the way on computing probability in previous example. Let's look at the case of 2 whites first. The first draw has probability 3 out of 5 for white. Because of non-replacement, 4 balls are left for the second draw, and 2 of them are white balls. So the second draw has probability 2 out of 4, that is 1/2 for white. To find the probability of both happening together, we multiply 3 over 5 times 1 over 2 equals 3 over 10. Similarly, the case of 2 reds. The chance is 2 over 5 times 1 over 4, which equals 1 over 10. By adding up, we get the probability of getting 2 balls of the same color without replacement is 2 over 5. What did we learn here? Without replacement, the probabilities change after the first draw. It is often easier to use combinations to count the number of favorable outcomes and divide by the total number of possible outcomes. So today, we learned 3 very important ideas in probability. Probability is favorable outcomes divided by total outcomes. When direct counting is hard, try the complement event. Use multiplication for, and addition for, or, when events are exclusive. These ideas will come up again and again. That is the end of today's lesson on Introduction to Probability. I hope you think carefully about these problems and practice more on your own. The more you practice, the more natural probability will feel. Thank you, and see you next time.